right, so far we've learned sum and difference rule, the constant rule, the power rule, the product rule, and now we have the quotient rule. At the end of this lesson, you'll be able to use the quotient rule to find the derivative of a function. All right, the quotient rule states let h of x equal f of x divided by g of x, so we have two functions being divided by each other. Then you'll notice we have this rule that we're going to follow to get the derivative. Notice we can't just find the derivative of each function and divide them. That just doesn't quite work nicely. So you'll notice it's kind of wordy up here, but let's just go down to the more simply stated one. We're basically going to be taking f prime times g minus f times g prime all over g squared. Notice it is somewhat similar to the product rule, because in the product rule we also have f prime times g and f times g prime, but this time instead of a plus, we have a minus, and then we're dividing by something. So we're going to go ahead right into examples and see how it works. Right, the first one says use the quotient rule to find the derivative. So I do have a quotient. I have a function divided by a function. So the first thing that I'm going to do, I'm actually going to write the quotient rule up here. It was f prime times g minus f times g prime all over g squared. Right, so this first function we will let be f, and the function in the denominator will let be g. And again, before I get started, I always like to set up my problem. I like to find f prime. The derivative of f will be 3, and for g prime, the derivative of g will be 2. So now I'm ready to go ahead and use the quotient rule. So the derivative of h will equal f prime times g, so we'll have 3 times 2x minus 3 minus f times g prime, so 3x minus 2 times 2 all over g squared, all over 2x minus 3 quantity squared. All right, from here I would like to get rid of the parentheses up in the numerator, so I will have 6x minus 9 minus 6x plus 4. Notice when I'm doing this, this minus is going to distribute, so when I do a minus, when I do negative 2 times 2, it's negative 4, but there is that minus there that gets distributed. That's why it turned into plus 4. And then it's still all over 2x minus 3 squared. So my derivative is going to equal, if I simplify this, my 6x's cancel out. I'm going to end up with negative 5 over the quantity 2x minus 3 squared. Please notice that I did not do anything with the denominator. When we go to solve these, it will be more helpful if it is in factored form. Right, next example. I have sine of x divided by x. Again, I know I need to use the quotient rule because I have a function divided by another function. So we are going to let the top function be f and the bottom function be g. And again, I like to go ahead and work things out before I even plug things into the formula. The derivative of sine, if you recall, is cosine of x, and the derivative of x would just be 1. So I'm now ready to go ahead and use the quotient rule. Okay, quotient rule is f prime times g, so cosine x times x minus f times g prime, so sine x times 1 all over g squared. Okay, then from here, for simplifying this, when I do cosine x times x, that does not become cosine x squared because this x is attached to the cosine. So if I rewrite this, it would actually look like x cosine x, and then minus sine of x times 1 is just the sine of x. It's all over x squared. And there's nothing else that I can do to this problem. I cannot cancel these x's because the sign does not also have an x. So at this point, that's as far as I can actually go. All right, last example. If I have x plus 1 over x. If you recall on the last example, not the last example, the last lesson when we did, we were just using sum and difference. We actually separated these, and you can get an answer that way. I just want to show you that also using the quotient rule, we could get that same answer. So we are going to let our top function be f. We're going to let our bottom function be g. And then f prime will equal 1. G prime will also equal 1. So when I'm setting up the quotient rule, the derivative, it's going to be f prime times g, so 1 times x minus f times g prime, x plus 1 times 1, all over g squared, so all over x squared. And then from here, let's get rid of those parentheses. 1 times x is just x. When I have this subtraction, I am going to distribute it. So when I distribute it, I'll get minus x minus 1. It's all over x squared. And then from here, if I just clean things up, the x's cancel out. I'm going to end up getting negative 1 over x squared. So that is my answer. I do just want to show you real quick if I would have done this problem the other way that we used to do it, that we did it in a previous lesson. I just want to show you either way is right, and you'll get the right answer either way. If I separated that into two fractions, I'd get x over x plus 1 over x, and then if I rewrote that, that would equal 1 plus x to the negative 1, and that was h. When I take the derivative, remember the derivative of 1 is a constant. 1 is a constant, so the derivative is 0. And then the derivative of this part will bring the negative 1 out front. It will be x to the negative 2. And if we get rid of our negative power, it will be negative 1 over x squared. So notice I got the same answer either way, and it's totally up to you which way you'd like to approach the problem. So hopefully now you can find a derivative using the quotient rule.